Alright guys, so the reason I'm making this video is to kind of help guide you through how you're going to go through class today. So just make sure you follow through this video. I'm going to kind of show you how to do what we're doing because today is going to be an introduction to the new unit, and then you're going to do some work on your own after that. Now the reason I'm not here, and kind of what you'll read right here, is that there's a chance we might be having our baby a little bit early, and so I've taken today off to kind of like help my wife out because she's pretty pregnant, and so it just was going to be really helpful for her to help her out today. So with that being said, today you're going to watch this video, okay, and you're going to do the work with me that is in the video. Then after that, you're going to go to step number 2, which is to complete the other stuff that I have left for you. So today will count as a classwork grade. Alright, and so just make sure you get this work done, at least to the best of your ability, and then turn this in before you leave today. Okay, just make sure you give it to the substitute teacher, or put it in my tray. Just make sure you turn it in so that I can have it. Alright, so let's go on now to, so I don't take too long on this video. This is called an introduction to inequalities. So go ahead and circle the word inequalities. Okay, now inequalities are similar to, but are not the same as equations. Okay, so this whole year what we've done so far is we've solved equations. Now that's actually our first blank. An equation is a statement that two mathematical expressions are equal. And sorry, I know the resolution on this thing's pretty low. Let me use a pen. Actually, it's probably gonna be easier to see. Alright, so an equation is a statement that its two mathematical expressions are equal. So, for example, 2x plus 6 equals 4. Go ahead and write that down. 2x plus 6 equals 4. Now, that's an equation. Okay, it has an equal sign, and what it says is that the expression 2x plus 6, so 2 times something plus 6, is equal to 4. Okay, so that's what that literally means in an equation, is that one side of the equation is equal to the other side of the equation. Okay, equal. Okay, equal sign. An equation means equal. Now, what's in this name right here? Well, unequal. So inequalities, meaning that one side of the inequality is not going to be equal to the other side typically. So that's the second blank. An inequality is a statement that compares. Okay, compares. Put a star above compares. It's a statement that compares two mathematical expressions. So now, we are not saying that they're equal. Okay, in an equation they're equal, and in inequality you're comparing the two sides. Okay, so you still have two sides. You have your left side and your right side. However, the left side and the right side might not be equal to each other. And so there's 4 signs of inequality, and y'all have seen these before in your life. I know you have. We have the first one, which is this. This is the greater than sign. Okay, greater than. Okay, meaning the left side is greater than the right side. So an example could be 5 is greater than 3. Okay, so that's greater than. The next one we have is less than. Okay, meaning the left side is less than the right side. So we could flip this around. We could say 3 is less than 5. Alright, now the next one, we probably see where we're going with this. The next one is greater than or equal to, so greater than or equal to. So this is the one that sometimes trips students up. This means the left side could either be bigger than the right side or equal to the right side. If you notice, we have the greater than sign, then part of an equal sign. So you could have something like this. This statement could be true. 5 is greater than or equal to 5. Now, is 5 greater than 5? No, but 5 is equal to 5. Okay, you could also have a statement like this. 7 is greater than or equal to 5. Because while 7 is not equal to 5, it is greater than 5. Okay, and so that's kind of how that works. And the other one we have is the less than or equal to. Okay, and so it kind of works the same way. We could have 3 is less than or equal to 3. Okay, that's perfectly valid because 3 is not less than 3, but 3 is equal to 3. Or you could have something like negative 8 is less than or equal to negative 2. Okay, because while negative 8 is not equal to negative 2, negative 8 is definitely less than negative 2. Alright, so here are some examples of how you may see, and this blank right here, again, is inequalities. So here's some examples of how you may see inequalities. Alright, so the thing is, inequalities don't just stay numbers. Okay, this is algebra, so of course we're going to incorporate variables. So let's look at the first term, or let's look at the first inequality rather. This says x is greater than 4. Now that means some number is greater than 4. So does that mean x can only be one number? No, it means x can be a whole bunch of numbers. Okay, x can be any number as long as it is bigger than 4. Could x be 3? No, because 3 is not greater than 4. However, x could be 5, x could be 6, x could be 7, x could be anything that is greater than 4. Alright, so we go to the second one. This says x is less than negative 2. Now that means for it to work, x just has to be any number less than negative 2. Now x cannot be negative 2 because it doesn't have the equal part to it. Also, it just has x is less than negative 2. So what are some examples of what x could be? Well, x could be negative 3, it could be negative 4, it could be negative 1,000, as long as it is less than negative 2. Okay, now x is greater than or equal to negative 7. Now, could x be negative 7 in this case? Yes, because it is equal, right? Now, x could also be negative 4. Okay, negative 4 is greater than negative 7. And then x, on the last one, we have x is less than or equal to 9. Well, again, in this case, x could be 9. Okay, that's perfectly valid because it's less than or equal to. X could also be negative 10 if you wanted, because negative 10 is definitely less than 9. Alright, so those are very basic examples. So this is how you apply a variable to your inequality, when the variable, pretty much what it stands for, is anything that is bigger than 4. Okay, x could be anything bigger than 4. Now let's continue on, and here's where we're going to start kind of learning the new stuff, because I think some of this stuff y'all already had in 7th grade math. So let's go ahead and start applying this to actual algebra. Alright, so inequalities, just like equations, can be solved. Okay? The process to solve inequalities is almost just like solving equations. Okay, it's literally, we've learned almost all the steps. So we can already, coming in today, just about solve an inequality. Okay, so let's read the first one. Okay, this says x minus 8 is greater than negative 3. So what does x mean again? Like, let's go back to basics. X means some number, right? So this is saying something minus 8 is greater than negative 3. Now, let's come over here and write it. Let's change this to an equation real quick. Let's say this says x minus 8 equals 3. Okay, so go ahead and write that. X minus 8 equals 3. Well, if this is an equation, how would you solve it? Well, all you would have to do is just add 8, right, to both sides. And you'll get x equals 11. Right, so that's a very, very basic one-step equation. X equals 11. Okay, so now let's take that principle and let's apply it to the inequality. The inequality says x minus 8 is greater than negative 3. Well, to solve an inequality, you just do the same thing as an equation. So over here, how do we get rid of the minus 8? Well, we added 8. So over here, if we want to solve it and get x by itself, let's also just add 8. Okay, let's add 8 to both sides. And I'm realizing now this is a negative 3, and I put a positive 3 here. That's my mistake. Anyways, though, so these 8s cancel out, and we get x not equal to. Okay, this is not an equation. This is x is greater than, what's negative 3 plus 8? Well, it's 5. Now, what does this mean? Does this mean that x has to be 5 for this inequality to be true? No, in fact, x cannot be 5 because it says x is greater than 5, right? So what that means is as long, so this is the big point, as long as you put any number in place of x that is bigger than 5, this statement will be true. let's test that real quick. What's a number bigger than 5? Well, how about let's do 10. Okay, let's just pick 10. So instead of x, I'm going to put 10. So now this says 10 minus 8 is greater than negative 3. Is that a true statement? Well, let's think about it. What's 10 minus 8? It's 2. So is 2 greater than negative 3? Well, it is. Okay, so what that means is as long as you put any number in this that is greater than 5, that statement's going to be true. All right, let's try another one. Okay, now this says g divided by 4 is less than or equal to 10. So if this was an equation, if we had g over 4 equals 10, how would we solve that? Well, again, that's a one-step equation, right? You can just multiply both sides by 4, and you'd be good to go. That'd give you g equals 10 times 4, which is 40. But again, this is not an equation, right? This is an inequality. But we solve it the same way as we solve equations. So over here, if we want to get the g by itself, let's just multiply by 4. Okay, multiply both sides by 4. That's going to give us g is less than or equal to 40. All right, g is less than or equal to 40. And again, what this means is as long as you put in place of g, as long as you put any number that is either equal to 40 or less than 40, this statement will be true. No matter what, this statement will be true. All right. So now let's continue on. And if you notice, it says let's add another step. Now, these were just single one-step problems right here. Let's do a two-step. All right, so we've added another step in here, so it's a two-step inequality now. So again, these differ from equations because they're not an equal sign, but rather what this is saying is that 3 times y minus 5 is either greater than negative 2 or equal to negative 2. So if this was an equation, we would get rid of the minus 5 and get rid of the 3. Well, let's just do that with the inequality also. So let's just add 5 to both sides. All right. And that's going to give us 3y is greater than or equal to 3. And then again, if this were an equation, we would just divide by 3. So we'll do the same thing. We'll just divide by 3. And that's going to leave us with y is greater than or equal to 3 over 3 is 1. And so again, just think about what this is saying. This is saying that no matter what you put in place of y, as long as it is equal to 1 or bigger, it's going to make this original statement, this original inequality, it's going to make it true. All right, so going to the next one. So we're just going to kind of go through these. We have 4 is less than 5x plus 24. So now the variable's on the right side, but again, just like with equations, that's okay. You can deal with it like that. So let's get rid of that 24. We will subtract 24 off of both sides. All right, 4 minus 24 will get negative 20, and that is less than 5x. All right, and then so for the last step, what we do, just like an equation, just divide by 5. Okay, so negative 20 over 5, I'm going to come up here, that's negative 4, is less than x. Now, the one thing you don't want to do with inequalities is leave the answer with the variable on the right side. So let's actually flip this. Okay, we don't want to change what it's saying, because if you notice x is on the bigger side, we just want to flip the whole thing. So let's say x is greater than negative 4. So this is how you want your answer. So with an inequality, never leave it with your answer having the variable on the right side. Just go ahead and move it to the left side. All right, and the last one for this page. Okay, p minus 4 divided by 2 is greater than 16. So here, if it were an equation, we'll just multiply by 2 because we want to get rid of that fraction. Remember, on these, don't get rid of that minus 4 first. Leave that alone for now, and we will just multiply by 2. All right, that's going to give us p minus 4 equals 16 times 2 is 32. Okay, and actually, it should be greater than sign, not equals. And then we'll go ahead and add 4. Alright, and so we'll get P is greater than 36. So again, we want to think about what that means, and what that means is as long as you put any number that is bigger than 36 in for the variable right here, the left side is going to be greater than 16. Alright, so we have the other one of these to do with this video, and it's kind of more of the same, except we're going to add a couple more skills in it. Alright, so there it is. There's one exception when it comes to solving inequalities. So for the most part, it's just like solving an equation. However, there is kind of one big difference. So when you divide or multiply by a negative number, you must flip the sign. Okay, so when you divide or multiply by a negative number, not just any number, it has to be negative. So if you divide or multiply by a positive number, that's not going to change anything. But if you divide or multiply by a negative number, you're going to have to flip the sign, meaning whatever inequality sign you have, if it's greater than, you have to flip it to be less than, and vice versa. So let's just solve this one. So again, if this were an equation, we could just add 6, which is what we need to do. So we'll add 6, and we'll get negative 4f is greater than 16. Then lastly, we'll just divide. Now, here's the thing. We're dividing now by negative 4. So since that 4 is negative that we're dividing by, what do we got to do to that middle sign right there? Well, we're going to flip it. So now instead of f being greater than, it's going to be f is less than. Okay, and then 16 divided by negative 4 is going to be negative 4. And that would be our answer right there. So this is the only way that solving inequalities differs from solving equations, because you can't flip an equal sign. It wouldn't change anything, but you can flip an inequality sign, and you only do that if you divide or multiply by a negative number. So in the other two examples of these are going to do that. So here we have x plus 4 divided by negative 5 is less than or equal to 4. So in this case, need to get rid of that fraction, and that being a negative 5, we have to multiply both sides, not just by 5, but multiply it by negative 5. Alright, so the negative 5's cancel out, and we are left with x plus 4. But since we just multiplied by a negative number, we need to go ahead and flip our inequality. We get x plus 4 is greater than or equal to negative 20. So again, when you're going through these, just be really careful of that. You have to flip your sign. So lastly, subtract 4, and we will get x is greater than or equal to negative 24. And the last one of this example is negative 3 is less than negative 2x minus 17. Alright, so we could add 17. Add 17. We'll get 14 is less than negative 2x. Alright, now what we're about to have to do, well, we could divide by negative 2. And now since we're dividing by negative 2, what are we about to have to do? Well, we got to flip that sign. So instead of being a less than sign, it's a greater than sign. 14 over negative 2 gives us negative 7. So we get negative 7 is greater than x. Okay, and now, so here's the part where students get tripped up a lot. Do we want to leave our answer like that? So we don't want to, because remember, with an inequality, you don't want your answer to have the variable on the right side. It needs to be on the left side. So let's just flip the whole thing now. So we have x is less than negative 7. Okay, this says the same thing as that. We've just flipped them. Okay, the x still is the smaller side. The negative 7 is still the greater side. So that works. Okay, the last thing really you can do with inequalities is you can graph inequalities on a number line. So not on like an actual XY grid, like a graph, but you can put them on a number line. And y'all did some of this in 7th grade, but let's go ahead and kind of talk about how to do that again. So this first one says x is greater than negative 3. Well, first of all, what that tells me to do is put a dot at -3. Now, there's two types of dots you could do. You could do an open one, okay, an open circle like that, meaning it's not shaved in, or there are shaded in circles, okay, and it just depends on what the inequality is as to which one you're going to do. So this is for this one, we're going to do an open circle, because you do an open circle if the sign is greater than or less than, okay, but not equal to. Okay, the shaded in dot is going to be for the greater than or equal to or less than or equal to. Now think about what this is saying. This says x is greater than -3, meaning x can be any number that is bigger than -3. Well, what side of the number line is greater than -3? Well, it's all these numbers this way. So what we do is we kind of like fill a line in this way and put an arrow on it. And what this is saying is that x could be any number as long as it is bigger than -3, and it cannot include -3, because if you were to put -3 in place of x, -3 is greater than -3. That's not true because it's the same number. Alright, so then we have x is less than or equal to 5. Okay, so this number line doesn't have a 5. Let's just go ahead and add one on it real quick. So 5. Now we're going to put an open circle or closed circle on it. Well, we'll go ahead and put a closed circle because of the equal part of the inequality. Because what that means is x could also be 5, so we want to shade that 5 in. And if x is less than or equal to 5, it means it could be any number also below 5. So we'll shade in to the left. Alright, so that is really the basic way to graph them. You cannot graph them until you've solved them. So like if you encounter something like this and it says graph and solve it, or solve and graph it, you have to solve it first, then you take that and put it on the number line. Let's see. Let's go ahead and skip that for a second. Let's just go down here to the final practice. So these are the last two problems we'll do, and if you'll notice, they're a little bit longer. But if these were equations, these would be pretty easy because we've done lots of equations like this. So now we're going to start doing inequalities with a few steps to them. So here, if it were an equation, we could distribute first, which is what we'll do. So 3 times 2x, we'll get 6x. 3 times -5, we'll get -15. Okay, then just bring the rest with us. Plus 4x is greater than 15. Alright, so again, solve it like an equation. So we'll combine like terms. We'll get 10x minus 15 is greater than 15. Alright, now we need to get rid of that minus 15, so we'll add 15. They give us 10x is greater than 30. And then our last step, as always, as usual, we'll divide. And that's going to be x is greater than 30 over 10, which is going to be 3. So we have our solution. Can x equal 3? No, so x cannot be 3. So because of that, we're going to put an open circle at the 3. Okay, we can't include 3 in our answer. It's just kind of our jumping off point. Now x is greater than 3, so we're going to draw our line this way, because what that says is x can be any number as long as it is bigger than 3. And if you're moving to the right on a number line, you're going towards the bigger numbers. And lastly, we have negative times 2y plus 4. So you gotta remember the trick to this, it's actually kind of like a -1. So we'll go ahead and multiply that. That's just going to make everything negative inside the parentheses. So negative 2y minus 4 is less than or equal to negative 3. Alright, and then so let's go ahead and add 4 to both sides. Okay, we'll get negative 2y is less than or equal to, that's going to give us positive 1. And then lastly, we can just divide. Now, what are we about to divide by? Is this a positive 2 or negative 2? Well, being negative 2, what does that mean we have to do with our middle sign? So that's kind of where we got to make sure we're kind of paying attention at. If you divide by negative, remember you have to flip your sign. So it's going to become y is greater than or equal to negative. Now you could do negative 0.5 because that's what 1 over 2 is, but I'm just going to do negative 1 over 2 like that. Remember, you can always keep it as a fraction if you'd like, or you can turn it into a decimal. as long as it's not a repeating decimal. Alright, so negative 1/2, that's not explicitly shown on the number line, but negative 1/2 or negative 0.5 is halfway between 0 and negative 1. So we're going to make our own point. Okay, this is negative 1/2 right here. Okay, and y is going to be greater than or equal to. So if it's greater than or equal to, what type of circle are we going to put there? And put a closed circle, because it's also equal to. And since it's greater than, we again are going to go to the right side. Okay, so that's the last of what we're doing today in this video. You'll just go ahead and complete the rest of what I left for you on top of that. Y'all have a great day. Thank y'all.